Hello and welcome. Today we're going to talk about the binomial theorem and Pascal triangle. First, let's look into this introduction. X plus y to the power 0 is 1. X plus y to the power 1 is x plus y. X plus y squared, just take this one here and times it by itself. You get x squared plus 2xy plus y squared. Now I can do x plus y to the power 3. I get x cubed, 3x squared y, 3xy squared, and y cubed. I can do x plus y to the power 4 now. Easily, I can see x to the power 4, and then plus 4x cubed y, plus 6x squared y squared, plus 4xy cubed plus y to the power 4. I can do x to the plus y to the power 5. I get x to the power 5 plus 5x to the power 4y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the power 4 plus y to the power 5. Now, you might think over time, I memorized those formula. No, I did not. Now, I will show you how I am doing this. So I'm going to redo that, the same thing. Now I'm going to add those terms in red. They're not really needed, but just to show you what's happening. You see here, the powers of x are going down from 2, 1, 0. And the powers of y are going up from 0, 1, 2. Here, 3, 2, 1, 0, powers of y, 0, 1, 2, 3. So this one here is the same thing. You see 4, 3, 2, 1, 0. And then 0, 1, 2, 3, 4. So if I know how those numbers now, coefficients are being calculated, then it's easy to find the formula. So you notice here when I do x plus y to the power 5, it starts always with x to the power 5, y to the power 0. It ends with x to the power 0, y to the power 5. Now look at those numbers. This 5 is coming from 1 plus 4. This 10 is coming from 4 plus 6. This 10 is coming from 6 plus 4. This 5 is coming from 4 plus 1, and then it ends up with 1. Starts with 1, ends with 1. So at this point of time, I think you can now, on your own, find x plus y to the power 6. So pause the recording and try to find x plus y to the power 6, and then come back to check your answer. Welcome back. So this is x plus y to the power 5. We know that this is, I already calculated that. And I need to find x plus y to the power 6. That's this one here. So I know I'm going to start with x to the power 6, y to the power 0. Now here, I'm going to have 1 plus 5, 6, x 5, y to the power 1. 15, x 4, y squared. Remember, the powers of x are going down and the power of y are going up. And then again now, 10 plus 10 is 20, x cubed, y cubed. 15, x squared, y to the power 4. 6, x to the power 1, y to the power 5. 1, x to the power 0, y to the power 6. Now, at this point here, if I am asked to find x plus y to the power 7, I can. But if I want to find x plus y to the power 9, I can't. I can't because I need the one before it to do that in order to apply this formula. So this is what we call the Pascal's triangle. So start from 1, 1, 1, 1, 2, 1. See 1, 1 plus 2, 3, 3, 1. 1, 4, 6, 4, 1. See, that's what we were doing. So if I want now x plus y to the power 7, these are the coefficients right there. Now, question, what is the coefficient of x to the power 14, y to the power 7 when we expand this x plus y to the power 21? Now, if you try to take this triangle, you have to go down all the way to line 21 in order to find the coefficient of this term. And that's not really practical, it's almost impossible. But the good news is those numbers here are combinations. So this is the Pascal's triangle, and it's also expressed in terms of combinations. Now, remember the formula for combination NR is n factorial over r factorial times n minus r factorial. And this is called Pascal's identity. So nr minus 1 plus nr is equal to n plus 1r. So here, see this here, 6, 1, 6, 2. When you add them, you get 7, 2. When you add these two, you get 4, 2. So now I'm going to try to prove this for you to show you how that's not too difficult to prove. So Pascal's identity, let's prove that r and n are positive integers and n obviously greater or equal than r. So I need to prove that this one is equal to this. So the left-hand side, by using the formula of the combination, is n factorial r minus 1 factorial n minus r plus 1 factorial, and nr is factorial n factorial r factorial n minus r factorial. So I have to add these two together, then I need to do a common denominator. This one is r factorial, this one is r minus 1 factorial, so I have to multiply this by r. And I have to multiply this by n minus r plus 1 to get this here. So now you do that. When you add these two here together, you get n plus 1 factorial over r factorial n minus r plus 1 factorial, which is the right-hand side. Now, we come to the binomial theorem. It's a very important theorem that you need to understand and be able to use. So x plus y to the power n is expressed as follows. Look at the powers of x are going from n minus 1 down to x to the power 0 here. The powers of y are going from y to the power 0 right here, 1 up to y to the power n. And we can write it in this form, which we will use down the road in this lecture. So it's the summation from j equals 0 to n, combination nj, x to the power n minus j, y to the power j. Now remember is the formula for nr is factorial, n factorial over r factorial n minus r factorial, with the understanding that n0 is the same as nn is equal to 1, and 0 factorial is 1. Okay, I'm going to show you a mathematical induction proof of the theorem. First, let's recall that x plus y to the power n plus 1 is x plus y times x plus y to the power n, which is x times x plus y to the power n plus y times x plus y to the power n, and that's the distributive law. Also, we're going to be using n0 is equal to nn is equal to 1, and the 0 factorial is equal to 1 for any non-negative integer n. So the basis step, when n is 1, x plus y to the power 1 is x plus y. I can write it like this, 1, 0, x to the power 1, plus 1, 1, x to the y to the power 1. When n is 2, which is really not really needed because this will be enough as a basis step, but just to see what's happening when n is equal to 2, x plus y squared, x squared plus 2xy plus y squared. And easily you can see this is in terms of combination 2, 0, 2, 1, 2, 2. And note that when n is equal to 0, x plus y to the power 0 is equal to 1, which is 0, 0, x to the power 0, y to the power 0. Now, inductive step, we assume the inductive hypothesis, IH. We assume that this is true, and we need to prove that this is true. So we take it one step up. This is n plus 1. Every n is replaced by n plus 1. So we need to prove this. So we start with our hypothesis, and I'm going to multiply this by x and by y, and then add. Multiply both sides by x and y. You get this when you multiply it by x, and you get this when you multiply it by y. Now I'm going to add these two, and I put this color here to see what happens because I need to add these two terms. I'm going to add these two terms. See, they are the same terms here, and then that's n0, n1, n1, n2. I will use Pascal's identity. So we add and use Pascal's identity. This terms will, this again here, this term will be here, and obviously this last term here will be here. So now when you add these two here, you get n plus 1, 1. When you add these two here, you get n plus 1, 2. When you add these plus this, you get n plus 1, n. And then you replace n0 by n plus 1, 0, because both terms are equal to 1. They're equal. And you replace n by n plus 1, n plus 1, because these two terms are the same and both are equals to 1. And that does it. Now, back to example 2. Now we can find the coefficient of x plus y to the power 21. And the answer is 21, 7, combination 21, 7, which is 21 factorials over factorial 7, factorial 14 factorial, and you get this answer. You can use a combination calculator online. They're available, really easily to do. But try, if you're doing it manually, don't you ever try to find 21 factorial, because you will not be able to do that. What happens is you can from 14 down, you simplify it with 14 factorial, and you will have 21, 20, 19, up to 15, because from 14 down, cancel this. 7, 6, you can easily find that to be equal to this using just a standard calculator. And you need to notice that 21, 7 is the same as 21, 14. So if by mistake you put 21, 14 here, it will answer be the same, because combination NR is the same as combination N minus R. Now we do some examples on your own. Now, what is the coefficient of x to the power 3, y to the power 7 in x plus y to the power 11? Pause and solve and come back, please. Okay, then the answer is 0. This term is not going to show when you expand this, because 3 plus 7 is not equal to 11. 3 plus 7 is not equal to 11. Okay, so that's kind of an interesting example. Now, what is the coefficient of x to the power 7, y to the power 3 when we expand this? Pause and solve and come back, please. Here we go. What is the answer? The answer is combination 10, 3. That's always going to figure out. Okay, the combination is going to be there. Combination 10, 3. Now, I'm saying, see, this 2 here is going to be raised to the power 7, and this 5 here is going to be raised to the power 3. 2 to the power 7, 5 to the power 3. Why? Because you can call all of this here capital X, all of this here capital Y. And now you have, by the binomial theorem, when you expand this, you will get this term. And then x to the power 7 is 2x to the power 7. That's 2 to the power 7, small x to the power 7. The same here, capital X, little x to the power 7. Here, capital Y, small y to the power 3. And 5 to the power 3. And then the answer will be, when you multiply these two together, you will see 2 to the power 7, 5 to the power 3, x to the power 7, y to the power 3. That's what this one here is going to be here. Then your answer is combination 10, 3, 2 to the power 7, 5 to the power 3. Now, on your own, what is the coefficient of x to the power 30, y to the power 70 when you expand 4x plus 5y to the power 100? Pause, solve, and come back, please. Now, easily now, you can see that you will have to have 170 as a combination, and then this 4 will be raised to the power 30, and this 5 will be raised to the power 70. Very easily. You can call this capital X, call this capital Y, and you do the same calculation here, and you find exactly that this number will be there, 4 to the power 30, 5 to the power 70. Okay, on your own, what is the coefficient of x to the power 7 when you expand this? So pause, solve, and come back. All right, here you see that I don't have y, but 2 is really the y. 2 is my y. So the answer will be 11, 4, 2 to the power 4, y, because in the expansion of x plus 2 to the power 11, you have this term, 11, 4, x to the power 7, y, this 2 to the power 4. So this number here will be added, will be multiplied by this number to give you the coefficient. On your own, find the expansion of x plus y over x to the power 100. Pause, solve, and come back, please. So now, using the binomial theorem, it would be sigma or summation from j equals 0 to 100, 100j, this term x to the power 100 minus j. This one is y now, 1 over x to the power j. And then you can combine these two together, multiply this term by this term here, and you will get x to the power 100 minus 2j. What is the term that does not contain x in the expansion of this? The same example of before when we expanded this. What is the term that does not contain the variable x? Pause, solve, and come back, please. Okay, the answer is 150. Why? Because this one we just did earlier. Okay, so now you don't want x to be there, so you need this to be 0. You need this to be 0. So you put 100 minus 2j is equal to 0, then j is equal to 50. Now, on your own, what is the term that does not contain x in the expansion of this x squared plus 1 over x cubed to the power 15? Solution. We're going to use the binomial theorem. So there will be j summation from j equals 0 to 15, 15j, and then this is your x, all of this to the power 15 minus j. This is your y, 1 over x cubed to the power j. Now you add these, you multiply these two terms together, you get this. Now again, you don't want x. You need term does not contain x. So this has to be 0. This has to be 0. So when you do 30 minus 5j equals to 0, you get j is equal to 6, and the answer is 15, 6. 15, 6, which is 5005. Example 10, find the expansion of x minus y to the power n. Now I'm introducing some negative numbers. So you use the same formula, the same binomial theorem. So I can put x minus y to the power n, x plus, and I put minus y in parentheses here to the power n. Then this is the binomial theorem. and you get here minus y to the power j. So minus y to the power j, n j, x to the power n minus j, y to the power j. So technically it's the same as the binomial theorem, except all the terms are alternating. Positive, negative, positive, negative. When j is 0, that gives you 1. When j is 1, gives you negative 1. J is 2, gives you 0. So for this example here, x minus y to the power 2, x squared minus 2xy plus y cubed. X minus y to the power 3, x cubed minus 3, x squared y plus 3xy squared minus y cubed. This is x minus y to the power 4, x minus y to the power 5. See the same coefficient here, except they are alternating. Positive, positive, negative, positive, negative, positive, negative. Now, on your own, what is the coefficient of x to the power 7, y to the power 3 in 2x minus 5y to the power 10? Pause and solve and come back, please. Now, the answer is going to be really easy now because you have the experience now. First of all, you have to have combination 10, 3. This is part of the formula. And then you raise 2 to the power 7, you raise minus 5 to the power 3. But when you raise minus 5 to the power 3, it becomes a negative. So again, you call this capital X, you call this capital Y, and you do the math here, and you find that you have negative 2 to the power 7, 5 to the power 3. Excuse me. On your own, what is the coefficient of x to the power 6, y to the power 7, minus 2x plus 5y to the power 13? Again, notice that 6 plus 7 is 13. That 13. This should be this. These should add to be equal to this. And answer is very easy now. 13, 7 minus 2 to the power 6 plus 5 to the power 7. Since the power here is even, then this will give you a positive number. Okay. On your own now, what is the coefficient of this? This is going to be really easy. Pause and solve and come back. Here we go. It will be 23, 7 combination, 2 to the power 16 minus 5 to the power 7. And since the power is negative, it will be a negative number. See, we just put it here like that first. And then you figure out, is that a positive or a negative number? Since negative 1 here is raised to the power 7, is going to be a negative number. We conclude by a couple of properties of Pascal triangle. First of all, look at this. I'm adding now these terms. I get 1, get 2, 4, add this here. You get 8, add this here, 16. So anything particular about these sums? This is easy. Those are powers of 2. Powers of 2. And therefore, the first property here, for any non-negative integer n, summation from 0 up to n j is equal to 2 to the power n. Why? Take the binomial theorem and replace x by 1 and x by 1 and replace y by 1. So you get here, this is 1, 1, that's done, 1, and then 1 plus 1 is 2 to the power n. You get exactly this here. Very simple. Now, I'm going to do the alternating here. 1 minus 1 is 0. 1 minus 2 plus 1 is 0, 0, 0. So nothing really here to worry about. It's all 0. When you're adding those, you get 0. And therefore, we have the second corollary. For any positive integer, n, summation from 0 to n minus 1 to the power j, nj is equal to 0. Again, you use binomial theorem and replace x by 1 here and y by negative 1. You get 0. By 1 here, and this by negative 1. So you get negative 1 to the power j ng. It's exactly this here. And that is the end of Binomial Theorem and Pascal Triangle. Please subscribe. Thank you, and see you later.